Does my hair look okay?
Hair looks great.
Looks fantastic.
I keep, they got these different backgrounds and things. I keep wanting a hair, like a hair app.
There you go.
Okay. Start.
Yeah.
Admit, I mean.
Yeah, I think we can admit people and we'll just give
Okay.
we'll give it a minute. Hi, everyone. Welcome. We're going to give it just a minute because we've got people coming in through the lobby. So exciting presentation coming up, but we'll start in about 60 seconds. Thank you. Great. Again, just allowing people to come in and join. We'll get started in about 30 seconds here. Great. Well, it's 2:02. I think we've got most of the folks that have joined us. My name is Aaron Smith. I'm joined by Nancy Bakeman. We're with the Energy and Environmental Building Alliance. And I'm really excited to have Bill Shadid and Troy Wilbanks here with us from AeroSeal, AeroSeal Envelope, and Aero Barrier. It's an incredible product. Bill, I think, and Troy, I had a chance to see an installation on this product maybe about a year ago. And it's absolutely incredible what it does. I think particularly with net zero homes, the zero energy home requirement, I think with air sealing requirements, where we're looking at getting to 1.5 ACH 50 within a home, this is a great tool in your toolkit. So standard rules apply. We'll have a Q&A section. Please feel free to answer your questions there or enter your questions there. I'll ask those questions to our panelists as we go through. This will be recorded and it will be on eba.org. We'll also put it on our podcast, which is Better Homes, Better Future, so you can listen to it in the car as well. So with that, Bill and Troy, welcome. It's always great to have you here, and we're looking forward to seeing you at the EBA Summit coming up in Salt Lake City, October 10 through 12.
Great. Thanks so much, Aaron. And you guys will continue to admit people as they come in from the lobby?
Absolutely.
Perfect. So, Troy, we won't worry about that.
All right.
Hello, everybody. Welcome to our webinar today. Troy and I are going to introduce ourselves very briefly in just a minute, but today, again, a reminder, our webinar is about net zero homes and really how air sealing a tight building envelope makes net zero homes much more achievable and affordable, even for a production level home builder. So we'll go ahead and get started and start moving forward. Our agenda today, basically the major topics we'll be covering. Waiting for the slide to advance. And are you guys still seeing the title slide, or are you seeing the second one?
Still title.
Title.
All right. Right again. Let me go back. There we go.
There you go.
Just a little bit of a lag. So we'll briefly cover introductions. Like I said, we're going to kind of set up net zero energy and zero energy ready as a topic, talk just about some basic definitions, and then the trends that are happening. Troy is going to cover air sealing a tight envelope and how that specifically applies to net zero and zero energy ready. I'm going to cover very briefly a little bit about the Aero Barrier product, and then we're going to cover two case studies, both a single family and a multifamily, that use the tight building envelope to actually make net zero basically achievable, not only affordable, but achievable for them as a project and as a builder. And that's, again, at both single family and multifamily. We should end with plenty of time at the end for Q&A. So please do submit questions, and we'll have plenty of time for that at the end. Troy, I'll let you introduce yourself real quickly.
Yeah, sure. My name's Troy Wilbanks. I'm the sales manager for AeroSeal Envelope, kind of formerly known as Aero Barrier, if you will. Yeah, so my focus and my team's focus is working with builders, raters, consultants across the board, really helping builders advance their building practices to achieve higher levels of building performance, including net zero ready and net zero. So.
Great. Thanks, Troy. And I'm Bill Shadid. I lead strategic marketing for what is now Aerosol Envelope, formerly Aero Barrier. Take 20 seconds and speak to that. Aero Barrier was our brand, actually, since we launched in the market 6 or 7 years ago. We've had tremendous growth, and we're still growing real fast. And so as a company, we also have a technology that sells ductwork. As a company, we've consolidated under the AeroSeal brand. And so AeroSeal is the name of our company, and it's our parent brand. And under that, we have two technology products. One is Aerosol Envelope, which is the product is still known as Aero Barrier. So we left the product name the same and just put it underneath our Aerosol Envelope sub-brand. And then AeroSeal Duct is the duct sealing technology. So throughout this presentation, you'll see us refer to Aero Barrier as the product and as the air sealing solution. So real quick, cover some basic trends and definitions around net zero. What is a net zero energy home? And even if a lot of people on this webinar might be familiar with this, but in case there's not, even for those who are, let's just kind of consolidate under a common definition. Net zero energy home is essentially a high performance, energy efficient home that produces as much or more energy than it consumes. And then when we speak to zero energy ready home, all that is a home that's been built, designed and built, so that once you apply renewable energy to that home, you will then be able to produce as much or more energy than it consumes. So a couple quick basic definitions, but kind of a good foundation from which to start this webinar. When we think about, HERS scores, and that's a very common thing, right, that we're used to looking at. When you look at the HERS scores over the years, they're falling, right? If you look on the right-hand side of the slide, the 2003 and 2006 IECC requirements, had a HERS score of around 100. By the time we get down to 2012, it's falling. And then by the time we get to wanting to be zero energy ready, if we achieve a HERS score of around 45 to 47, and then apply a renewable energy source to that, we will achieve a net zero home. So just again, that trend's been happening for a while, the HERS score falling. It just needs to get even lower to achieve net zero or zero energy ready. And again, kind of a good reference point for us. Why are we talking about net zero now? Well, if you really, follow the housing industry, and again, this is both for single family and multifamily, demand for net zero is increasing. When we talk about net zero as a trend or the future, we like to say it's not the future, it's now. And I'll show you a couple examples of that just in a couple slides. But it's growing very, very fast. There's consumer interest and demand. There's increasing financial incentives, such as the Inflation Reduction Act that was passed about a year and a half ago. So more builders are actually including net zero in their offering to consumers or plan to do so in the very, very near future. And let's look at that real quick. This was some data from EBA Team Zero, which is part of EBA. So thanks so much for this great data. But if you look at this chart, really don't need to go into a ton of detail, but you can just see from left to right, going from the year 2015 to the year 2019 to 2020, just the drastic increase in terms of projects, buildings, and number of units. And what's really interesting to me as well is that if you look at the gray bar, which is number of units, that's actually growing faster than the number of buildings and the number of projects. So what that says is you've got really more multifamily that's been coming into the spectrum. And that's really cool to see multifamily hitting net zero and zero energy ready. And we've been, like, as I mentioned at the end of this presentation, we'll be talking about a very specific multifamily project. From a geography standpoint, you can just see the little circles. That's where greater numbers of net zero homes have been reported. But you can look at the color from, even the beige, there's 0 to 9 units. This was from the 2019 to 20 Zero Energy Residential Building Study, the report that was done by the EBA Team Zero. But looking at, the dark blue to purple, like California and a province in Canada, where they're doing, 5,000 plus units. So this isn't just isolated to one part of North America, it's occurring everywhere. Now let's look at the increasing incentives for net zero. These were the 45L incentives that were increased and made more permanent, meaning that they didn't need to be renewed. They're good for a 10-year period. And we look at, both whether it be Energy Star on the first row or Zero Energy Ready on the second row, and you can see what they've been increased to. If you build a single family Zero Energy Ready home, the builder can get $5,000 per home. That's very, very serious money. For multifamily that's not prevailing wage, they get $1,000 per unit. And for multifamily that is prevailing wage, they get $5,000 per unit. And you can see even that the incentives for Energy Star are substantial as well. So again, this just fits into that trend that we see of more and more happening to support the design and construction of zero energy ready homes. Another thing I think that was really cool to see is that from ResNet, we looked at an honor roll of builders. This was from 2020. And what's interesting, what we need to look at here, I don't think is the detail, because it's a long list of builders that were actually pioneering and building some net zero energy homes in 2020. But if you look at some of the builders that are mentioned, there's a top 5 home builder of Lennar Homes who's actually in that listing twice. So this isn't just, say local or regional, more specialty builders. Even the largest home builders are really taking net zero and zero energy ready seriously. And that's actually supported very much by Beazer Homes, who's a big customer of ours. But they, in 2021, in their ESG summary, they made a commitment by the end of 2025 that every new Beazer home will be zero energy ready and generate a HERS index score of 45 or less. And think about somebody who's building several thousand homes a year to make that commitment. It's a very, very big deal. And I think it says a lot of good things about where our industry is going. Even Pulte has basically got content out on their blog and their website that speaks to what is net zero, how we're going to get to net zero. So again, some of the biggest home builders are really addressing this and moving forward with it. So it just speaks to the growing trend and the growing demand. And again, what we're going to cover today is how a tight building envelope can help you achieve the same thing. So I'm going to turn the presentation over now to Troy, who's going to take us through a number of slides around air sealing. And Troy, just whenever you want to advance the slide, you tell me and I'll hit next.
Perfect. Bill, definitely appreciate it. So yeah, as Bill just mentioned, I'm going to cover, air sealing the envelope. I'm going to cover it at a very high level, cover some of the basics surrounding, surrounding kind of what air sealing is, the control layers, what we need to focus on, some of the benefits and challenges, some of the questions, and then also going to focus on, how proper air sealing can impact the build as a whole, the durability, as well as some areas that we can, help address costs. So, Bill, next slide. Not the slide I was thinking, but let's roll with it. So, when we're talking about air sealing and getting to net zero ready, air sealing is a huge component of that, right? When we're maximizing the efficiency of the build of the HVAC units, really, everything that's put into the structure, none of that really matters. We effectively leave the front door open all the time. So air sealing is a major component of that. It's going to make sure that the building operates as a system as designed. And you can see the quotes here. Not going to do the death by PowerPoint and read those individually, but you guys get the idea. One key takeaway from this, though, and we're talking about air sealing and net zero, and really any effective build for that matter, is being able to come up with a repeatable and reliable air sealing detail. one that through modeling, we can say, okay, in modeling, we're going to model at 1.5 air changes per hour, or if we're talking passive house, 0.6 air changes per hour. Not modeled as a relatively tight house or a tight house, but really be able to narrow that down, knowing that that's our goal and that's what we're going to hit, and here's how we're going to hit it. Doing so, you can, we'll list quite a few impacts that are covered in the Wasatch case study here at the end, but we can, reduce the size of mechanicals, change out insulation packages, do all of this, right? Reducing capital expenditure while getting the same, if not better, performance out of a build. So next slide, Bill. This is a good example of that. So when we're talking about, builds in general, but specifically, net zero ready or net zero homes, the difference between net zero ready and net zero is adding on renewables such as solar panels. One of the things that we can do through effective air sealing is reduce that capital expenditure cost of those solar panels up front. And you can see this chart right here on the left-hand side, as we see the air changes per hour or ACH level. And as that drops, the estimated number of solar panels is reduced drastically by 67 to 77%, because by reducing the air infiltration, we're reducing the load requirements. This is very important for a couple reasons. One, you can see that net zero ready, net zero type level of air tightness at 1.5. Yes, that estimated number of solar panels, it's much, much less than, say, at 5 air changes per hour. But if we have an aggressive air sealing detail and execution that's repeatable, and we could take it down to that 0.6 or 0.5 level, reducing that capital expenditure up front. Not only if this is a true net zero home where you're going to be installing these panels, but also when we're talking about marketability and total cost of ownership for home buyers, if it's a net zero ready house, right? The plugins are there. All they have to do is get the solar panels and hook everything up in the future. This is a huge point that in the future when they do move from that net zero ready to true net zero, that total cost of ownership, not only of the original purchase, but maintenance upkeep is going to be much, much lower compared to another house. Also, when we're talking about things like solar panels, and really all aspects of the build, if we're looking at the total carbon footprint, really looking at the carbon analysis, reducing any type of manufactured product is going to reduce the total embodied carbon of the build. So, increasing the level of air tightness, reducing the air infiltration can really hit on some major points beyond hitting that 1.5 level. Potentially getting lower, and I outlined quite a few of those right there. So next slide, Bill. So this, why is air sealing the building envelope so important? This was originally going to be the first slide to kind of kick it off, but like I said, let's roll with it. So arguably, air sealing has the greatest impact on any build when it comes, through the full process from design to occupancy. The DOE estimates that uncontrolled air leakage accounts for as much as 40% of energy use, which is a massive number. Now, that's the DOE estimate based on kind of code-built houses. When we're talking about net zero houses, that 40% is going to be knocked down to essentially zero. Net ready, depending on when the renewables are plugged in, is going to be drastically reduced. So air sealing the building envelope when it comes to efficiency is huge, right? And we can see that through study after study. Also, there's a lot of impacts, which I'll cover here a little bit further when we're talking about protecting the integrity of the build through the total ownership of the home. And also a lot of the negative impacts that can happen to a build if they're not addressed correctly. So next slide, Bill. Benefits of reduced air leakage, there's a lot. The one listed up top, the first one, that's where we typically think, right? That's where our mind goes, is increasing efficiency of the build. Obviously, by keeping that conditioned air inside, it's going to exactly do that. The HVAC is not going to have to run near as much as possible, and the building is going to operate as a system as it's designed to do. Beyond that, though, I like to call them the butterfly effects, if you will, of proper air sealing, and that's when we're really getting into the occupant comfort, right? Building a structure and ensuring that the people that are in it really receive, the maximum capabilities of that structure, whether it's living in, going to school, whatever that structure may be. And a net zero home is going to do exactly that. So through proper air sealing, getting a really tight building envelope, you're going to have less pest intrusion. So less bugs getting in from the outside. Also, you're going to drastically reduce the transfer of smells and sounds. This is huge in the single-family detached world, whether you're in a rural location or out west, or dealing with pollen, or in some cases wildfires, or more of an urban area where there could be a lot more fumes from traffic floating around. That also then multiplies naturally so in the multifamily type world, right? Where noise and smell are the number one and number two complaints by property management companies. So tightening the building envelope, single family detached, is gonna help benefit the occupant, while compartmentalization in the multifamily space is definitely going to have a major impact, not only on the individuals themselves. They don't want to hear, what the music that their neighbor's listening to, or smell exactly what they're cooking, but has massive benefits for the property owner, which could potentially be your client. Expressing to them through proper air sealing, through going to net zero ready. There's going to be a lot of positive impacts on the tenants or the occupants. So, next slide, Bill. So where does air leakage occur? This is a very, very interesting slide. When you ask the average person where they think air leakage comes from, what I hear is windows and doors. That's typically where you're going to feel the most drafts, just in your day-to-day life. But study after study is showing that the total amount of air leakage, really the lion's share, is coming from the ceilings, floors, and walls. Ducts are second. You guys can see the rest here. What I find so unique about this is the majority of things that are listed, whether it's fans, windows, doors, fireplaces, things like that. Those are things that you can buy a better version of, that is going to have a marketability of much, much greater air tightness. When we're talking about ceilings, floors, and walls, right? You can't go and buy air tightness, right? You can buy improved HVAC. You can buy a lot of the things that make a net zero ready home net zero ready. One of the ones that you cannot buy, though, is air leakage. Also, you cannot really buy that experience necessarily to identify where this air leakage is happening and properly air seal. So it's a huge challenge that we have, and we'll hop into it a little bit more in detail, later on in the slides. Excuse me. But it's interesting. It's an interesting fact, and what this tells us is sealing the building envelope, coming up with an aggressive, repeatable air sealing detail that will address where the lion's share of air leakage is coming from, is a crucial component as you're approaching a net zero ready build. Next slide, Bill. How tight is tight enough? I get this question a lot. Generally, when we're talking about just meeting code, but often we're talking about net zero ready. I do like this image that's put up here, the space station. Do we need to steel as tight as the space station? Not necessarily, right? There's a lot more negative impacts for not sealing the space station compared to sealing a house. Some might argue that, but I guess we're not going to dive down that rabbit hole. But when we're talking about how tight is tight enough, there's really, three things that we need to take into consideration. Well, first, from the building science view, every house should be sealed as tight as possible, but designed properly for it. So the first thing we want to look at, the very basic, is compliance requirements, right? For net zero ready, typically what we're saying is, that 1.5 air changes per hour. Are we developing an air sealing detail that's going to meet that? The next one is, okay, we know now that we're going tight, right? Especially compared to a code built house, we're going to that 1.5 air changes per hour or below. Are we working with our HVAC folks? Are we working with our MEPs to make sure that the mechanicals are sized properly? Which, as we know, the tighter or leakier a build is compared to the proper sizing of the equipment, can have positive impacts or negative impacts as well. And the building owner's goals are huge. One of the reasons why I like to put that on the slide is this is an area where we, can go out of our way. We should be going out of our way to really relay and convey the benefits of a net zero ready build to building owners, whether it's a client that you have that's looking to build a house, whether it's a production builder that you have that you're trying to transition over to the net zero ready world, or if it's a multifamily developer that you're working with. The building owner, they have specific goals. A lot of them are wrapped up in costs, right? Whether that's hard costs as far as construction materials going in, or profitability as far as what can you sell the house for? What's the marketability of the build? How does it impact your brand long term? When with property development companies, we're really hitting a lot on not only the compliance aspect and the mechanicals, but also what is going to be your operating costs? If we're going to, and how much can you charge for rent, if you will? If you're providing an excellent living space for individuals, you can sometimes charge a little bit more of a premium for a more luxury and sustainable build. Also, if you're looking at holistically building a net zero multifamily building, you're going to have a massive reduction in your operating expenses. So, there's a lot that goes into to the building, or there's a lot of impact that we can have on building owners' goals beyond just the efficiency aspect of a net zero build, which is going to sway them. It's going to convince them that that this is definitely the way to go if they're not already convinced. So, next slide, Bill. Yeah, one of the things that we need to address in any build, particularly when we're looking at a build that has the efficiency requirements for net zero ready, is providing a complete thermal enclosure. Really, addressing the four key components of that. Once again, I said this is pretty basic, so if anybody wants to go further in depth, feel free to throw in questions, or we can set up a time later to discuss each one of these. But really addressing first your air barriers, addressing thermal bypasses and preventing wind intrusion. To that second point, air sealing, that's a broad topic. What are we air sealing? Is it the building envelope? Is it the ductwork? How are we doing it? Is it foam? Is it tape? Is it caulk? Is it spray foam? Are we trying to go with more environmentally friendly products, so we're eliminating spray foam? What does that look like? Excuse me. Also, advanced insulation. With any net zero ready build, we're going to take a look at what that insulation is. What not only the advanced insulation, but any advanced air sealing detail that comes along with the scope of the insulation company, and also advanced windows. This is an area that I run into very often, where we'll come in. We're sealing a house and we're wanting to get it down to down to 1 or 1.5. So we do some testing. So we'll tape off the doors and windows and do some instance testing along the way. And if you're not really addressing these windows, lots of times we're seeing as much as 3/4 to a whole air change brought into the build just by the windows alone. So take a look at the specs of the window manufacturers. Make sure that this is not an area that's going to turn around and kind of bite you at the end when we're coming through and doing blower door testing. So
pro tip, Troy, stay away from sliders. Sliders are
yes.
notorious for air leakage.
Thank you, Aaron. Thank
Yes.
you. Next slide, Bill. Yeah, and then obviously, following on the coattails of that, from the beginning point of view and kind of the holistic approach to the build, we want to mitigate risk, and do that upfront as necessary in the design phase, and monitor it through construction. So first thing we want to address is bulk moisture. Bulk moisture can have just about as as fast of a negative impact, short of intentional human action, right? Then airflow controls comes in there at that number 2 spot. The reason why it comes in that number 2 spot is because the massive impact it has on the build as a whole. Specifically, that number 3 and number 4. Your thermal control. So we're talking your HVAC and your insulation as well. Is it going to perform as designed? And also your moisture and vapor control, which is exactly that. Controlling the amount of moisture and vapor that's entering and exiting the building. So, next slide, Bill. Yeah, right on the following up to that, I really like showing this slide. One, it shows naturally what everybody can see, how condensation occurs and how air sealing can prevent it. So, in this slide right here, it's representing kind of a cold weather climate in the winter. You can think, the same concept, working principle can be reversed if we're looking at a warmer climate in the summer. But the idea still stands. So we have the warm, moist air on the inside that's leaking into that wall system through that leak path right there that you see. It's hitting that cooler exterior sheathing, and all of a sudden that moist air is condensing into liquid water. We obviously do not want this to happen. This can open up room for mold, mildew, wood rot, all types of issues that can really reduce the integrity of the build and could potentially, have negative impacts on the health of the homeowner when we're looking long term. Another reason why I really like this slide is it's showing something that isn't so obvious, and it's really what air leakage is doing to the insulation. So, in this wall system, we're looking at fiberglass insulation. The R value of insulation is derived in a lab type setting where everything is completely controlled and accounted for. We know that in real life that's not the case. So, as air leakage is going into that wall, it's the air is going into that wall system. It's going up and down through that insulation and really having a negative impact on the performance of said insulation. So the end occupant really isn't getting the benefit of that specified product. What does this mean for us when we're talking about the expenditure and insulation selection up front? What it means is it opens the door for us to look at other types of insulation, potentially more economical, that will perform just as good, if not better, if we get complete control over the air leakage to ensure the air is not leaking into that wall system and compromising that R value. So, next slide, Bill. Moisture control. I love this slide. I'm sure most people have seen it, but I still really like to use it. And this really hits on what we have control over, what we should be able to control, and the protecting the integrity of the build and the performance of the build and the comfort of the occupant. So on the left hand side, we have vapor diffusion. This happens naturally, and in this scenario, over a period of about a month, you have about a third of a quart of water enter this wall system, and then it'll just dry out, evaporate out. That's no harm, no foul. That's what these systems are designed to do. Then the whole game changes, though, when we introduce air leakage. And in this example, it's something as simple as entering a 1-inch hole into the equation. You can think of that 1-inch hole as taking a jigsaw and literally cutting out a 1-inch hole. But what we're seeing in real life is typically what this is death by 1,000 paper cuts. So this 1-inch hole is the accumulation of numerous different cracks and leak points that were missed during the manual air sealing process that add up, sadly, to way more than 1-inch hole on the average house that we see. But, what does that mean during the same month time period when it is a 1-inch hole? Well, all of a sudden, that third of quart of water turns into 30 quarts of water. And that's over that same period of time of about 1 month. Oh, Aaron, were you going to say something?
No, it was just somebody coming in. I just let
okay.
them in. Okay. Late arrival.
So naturally, the air leakage is something we can control. So eliminating that 1-inch hole is going to eliminate those 30 quarts of water from entering the build. So next slide, Bill. So the whole point of this slide is to really show where the industry is going. And we are leading the industry when we're talking about net zero ready builds. Bill had a slide earlier in the presentation that kind of hit on this, but it's very, very important. As we see code getting tighter and tighter, it's requiring tighter building envelopes. And when you look at the total air leakage requirement for houses in 2009, the IC requirement, basically what it added up to is about a 15 by 15 hole. If you took all those leak points and added them up, that gets tighter, when we're looking at the 2015 ICC code, addressing it down to a 13 by 13 hole, 2018, 10 by 10, When we're talking about a net zero or net zero ready house, that 10 is looking more like a 3x3 or a 5x5. That when you take all the leak points in a house and add them up, that is a small, small hole. Now, naturally, if you ask the person that you were building a house for, how big do you want the hole in your wall? They would say they don't want a hole, period, right? But that's what essentially where we're going with net zero ready. Is making reducing that air leakage to a much smaller and smaller amount. We know, for if to improve the efficiency of the build, and maintain that efficiency throughout the life of the structure. Also, the butterfly effects that we talked about before, but if this is the direction that you're looking to go right now, you definitely need to start preparing. And if it's something that you're, kind of just watching as far as when is code going to require it, it's going to require it sooner than later. So addressing a lot of these issues with air leakage, the one thing you really can't buy at a store, is going to be crucial. And addressing them now and coming up with an action plan, the necessary steps to achieve these goals, it's gonna benefit everybody, exponentially moving forward. So, next slide, Bill. Challenge with air sealing, there is a lot. The number one, the challenge that I hear about is the trades. And I don't want to talk, negatively about any trade at all. It's just the reality of it. It's not anybody's primary scope of work. Yes, your insulation company will have an air sealing, line item attached. There's expectation for the plumbers and the electricians, but it's not their primary scope of work. I mean, an electrician didn't become an electrician with the vision of walking around a job site, air sealing any more probably than anybody, attending this webinar today chose their profession and worked really hard to, achieve the level in their career that they're at. You didn't start out thinking, air sealing. That just wasn't part of it. So since it's not somebody's primary scope of work and it's hard, it gets missed a lot. It really does. I mean, chasing air is the analogy people use to describe other things that are hard, but in this case, we're actually chasing air. And along that, there's a lot of other challenges that a lot of folks are familiar with. What materials are we using? Caulks, foams, gaskets, are there compatibility? What caulk are we using for a bottom plate? Going back to the trades, or are we sweeping or bringing in a blower to get rid of the drywall dust to make sure that the caulk actually adheres? What combination are we looking at, and also knowing where to seal. It's a huge challenge. Obviously we focus a lot on the exterior walls, but you would be amazed at the leakage on interior walls as well, in door jambs and whatnot. So next slide, Bill. Overall, though, getting it right really, really matters. It matters on any build, but when we're talking about net zero type structures, it matters even more. The effort that we put into this is extensive. The costs, that we put into this, really, really matter. And failing that blower door test at the end can really compromise everything. If everybody's been on a job site during a failed blower door test, it's not a pretty thing to be a part of. Lots of finger pointing because it's nobody's primary scope of work, and rework can be extensive. Ripping out cabinetry, baseboards, rolling back carpet, additional ceiling. It can get pretty extensive. So, next slide, Bill. I like this slide. One, it shows kind of the mistakes that were made, but I love the quote. To mistake is human. To blame it on someone else, that's even more human. If you've ever been on a job site when a blower door test was failed, that's exactly what happens. The PM or the builder, the GC, whoever's in that role, oftentimes insulation companies first people that they call, they have their punch out guys wondering what they missed. Okay. Now, framers, let's call them back, and nobody's raising their hand saying that was my bad. When you flip a switch and the light doesn't turn on, you call the electrician. When you fail a blower door test, there's not necessarily, in traditional builds, there's not necessarily one person that you call. So managing that is challenging. Next slide, Bill. So what's the solution? When it comes to air sealing, I've worked with single family builders, multifamily builders, worked with a whole bunch of folks, raters, and really the point of this slide is to really jot down and convey to everybody, some of the best practices, the best recommendations that I've seen. The first one is defining a goal in the design phase and communicating it across all parties, letting everybody know we're building a net zero house. Here's why. The air sealing detail is crucial for to execute on, to ensure that this house passes the blower door test, and is verified and is truly a net zero house. Letting people know that this is wrapped up in their primary scope of work. They will focus on it better. They will do a better job. Also, developing an air sealing detail with accountability. This comes in a couple ways. One is instance testing. A lot of focus in the job site walks and QA/QC process, but also, people think accountability, they also think of it as kind of a negative. The opposite is also true. When we see people, individuals, break it down to the human level that are doing a really, really, really good job, reward them for it. Kind of put their name up in lights. Who doesn't like that? Encourage them to in pre-con meetings to tell them and exchange best practices with the other trades. It can go a long way. Educating the trades and letting them educate you. That kind of goes into what I just talked about, as well as defining the goal up front. And then also relying on manufacturer for new product capabilities and updates. Appreciate everybody attending today. This is one that is fun to do, but I get it, right? We all have our jobs that we're focused on. This can often be looked at as kind of outside the norm, but really reaching out, attending, events like this, being engaged with EBA, is a huge way to really be aware of what else is out there that could potentially benefit your net zero ready build. And then also the inverse is true, things that may have not performed so well historically that you might want to kind of stay away from. Specifically, Aaron had brought up, I brought up Windows, and Aaron brought up a very good example of something that you might not want to consider if you're, really going for a net zero house. So, next slide, Bill. And I think that pretty much wraps it up for me.
Yep. Thanks, Troy. Appreciate that.
Thanks, sir.
So I'm just going to do a very quick overview of the Aero Barrier product, the Aero Barrier air sealing technology solution. So just one slide that gives a quick overview. You can see on the right-hand side of the slide a section cut through a house, and you can see kind of a bunch of what looks like little beige colored kind of a mist or a fog. And really that's what we're doing. We're pressurizing a house, and then we're emitting a fog of sealant into that house, and then letting the air currents that are naturally going from higher pressure inside the house to lower pressure outside the house or the multifamily project to essentially, the only way to get outside is to go through leaks in the building envelope. It carries our sealant through those leaks and then plugs them. But we use essentially the benefit statement, guaranteed air sealing made easy, because it says a couple of things very, very quickly. One, what do we do? That's air sealing. Two, why should you care from a benefit standpoint, or what pain points is it solving for you? One, we guarantee it. In other words, when we're done, you're able to see exactly the air sealing requirement or the air tightness level you've achieved. And then to number two, we make that very, very easy. So benefits of guaranteed, easier, verified is really important, because we're running a continuous blower door test, the entire time we're sealing your project. Also from a multifamily standpoint, those of you who've done those projects know that compartmentalization, party wall sealing between units or between a living unit and a common area or public area can be very, very difficult to find the leaks and then get them sealed. And again, because we're just using the concept of air going from high pressure to lower pressure and air currents following that direction, carries our sealant to those leaks and seals them. So we make that a lot easier. What I'd like to do now is just show you a short video. It's just about 3 minutes long, and it's a computer animation that really explains how air barrier works. So I'm going to go ahead and play that, and then I'm going to narrate it a little bit as we do so. So what we're trying to show here is a single family home, and I think the video is going to catch a little bit when we first start, but then it should smooth out. We're essentially doing some prep work. That's our first step, where we're covering design mechanical openings or a fireplace opening or any area where we do not want sealant to get into. And we're typically applying right after drywall and the first coat of mud, although we can also do aero barrier, apply aero barrier before drywall, depending on where you want that air barrier to be or the air sealing barrier to be. Next, we start to bring in our equipment. We bring in sealing stations and distribute those throughout the home's interior. We're then putting our equipment on an exterior entry door. It can be from inside the garage or through the front door, side door, back door of the house, depending on the house's layout. It includes a main control unit, a centrifugal fan, laptop, some lay flat tubing. Now we're going to pressurize the house. I mentioned earlier, we're applying higher pressure air to inside the home. So you'll see now the blue arrows represent basically air going into the home and pressurizing it. You can see it kind of going through windows and some leaks because that air, again, is going from higher pressure to lower pressure, and it's doing that by going through the leaks. We set up a Wi-Fi mesh network. That's really important because now we're controlling every seal station from the laptop and main control unit. And then we begin emitting sealant into a mist or fog into the space. You'll see next in just a second, you'll see that same house section, and you'll see at the top or on the left where the sealant is going through the leaks into the outside or into the attic, and then slowly or quickly, actually, I should say, those leaks are sealed, so the sealant no longer passes through. It can be windows and doors, electrical outlets, can lights going into the attic. We're also, as I mentioned before, we're running a continuous blower door test, I'm sorry. So we're able to actually every 60 seconds report where you're at from an ACH 50 standpoint. And that allows you to know where you're at versus your requirement. Here's some close-ups of how the sealant gets pulled into a leak, an electrical box. Here's underneath the sill plate. The next example will be either a plumbing penetration or electrical conduit penetration through an exterior wall. So you can see the air current that's just going outside to get the lower pressure, carries our sealant and sticks and plugs that leak. Our sealant will not stick to anything but the leaks. We can have separate conversation about the physics and chemistry that make that happen. Essentially, again, as I mentioned, we're reporting those results every 60 seconds, showing that you hit the goal. Actually, the goal for this test animation was net zero. Now we remove the prep work that we had put over designed openings where we didn't want sealing to get in, remove our equipment, and we're done. When it's all said and done, you get a envelope sealing report that shows you where you started and where you finished. In this case, in this home, the starting ACH was 7.34. We got it down to 1.5. It's about an 80% reduction in air leakage. So I think that video does a nice job of kind of, giving an overview of how air barrier works. And then just finally, very quickly, then we'll jump into case studies. We do serve customers in these market segments: single family homes, multifamily homes, and even commercial buildings, including some very, very large commercial buildings. And we are both US, Canada, as well as international in terms of where we're doing air sealing today. So now let's get to a couple case studies that are really good examples of how getting a tight envelope helped a builder achieve net zero or zero energy ready. In this case, it's Mandalay Homes in Arizona, about 45 minutes to an hour north of the Phoenix metropolitan area. They build a lot of zero energy ready homes, but just a couple, 3 years ago, their goal was really to determine the best path to achieve zero energy ready for literally every home they built. Okay. And they did a lot of analysis and a lot of modeling, and they concluded that if they could get a tighter building envelope, that would enable them to achieve net zero and make it available even to a production level home. So they compared aero barrier to other methods of air sealing, did choose aero barrier, but the results of this then were they were doing a pretty darn good job of air sealing their envelope down to 3.1 ACH 50 before they applied aero barrier. But aero barrier was able to get them down to 0.6 ACH 50, which is, well below the 1.5 that is normally targeted for for net zero or zero energy ready. 0.6 is a passive house requirement. What that allowed them to do is really only need to use 8 to 14 solar panels needed versus 30 to 60 solar panels. That allowed them to achieve savings of up to about $50,000 per home in capital costs, and therefore allowed them to offer these homes to even the average American home buyer. Next, let's look at a multifamily project. This was a really interesting project in Utah, 600 units, so not a small multifamily project. And their goal from the outset was to try and achieve net zero, and they wanted to be all electric if they could. The project is called Soleil Lofts, and the client was the Wasatch Group, the developer and builder. We actually had a quote from them talking about how getting a tight envelope was, for them, the best way to get to the most affordable and effective way to get to net zero. And so you can actually see that on the lower right of this slide. But again, they determined that they needed to cut energy consumption in half to be able to meet that zero energy ready requirement, the performance target. And they did a lot of extensive energy modeling. They looked at appliances and lighting and other things, and it showed that air sealing the envelope was the best option. They then concluded that using aero barrier to air seal the envelope was the best option for them, and that's how the project proceeded. So they were able to take their typical 3-bedroom unit, had been designed and were modeled originally to use a 3.5-ton gas furnace. Once they were able to get the exterior envelope down to 1.0 ACH50, or just a little bit under, we hit a minimum of 1 ACH50 and sometimes just a little under on every one of those units. They were then able to switch over to a VRF electric system due to that air sealing, and that down to 1.5 tons. So the results of that provided were, again, we sealed down to 1 ACH50 or slightly below on every unit. They used that smaller system, and then were able to go all electric. It saved about 50% reduction in actual HVAC cost, provided a 50% reduction in energy use, and that supported the use, allowed them to afford to put photovoltaic solar on the project. They happened to have utility rebates for where they built in Utah that ended up totaling substantially more than the cost of aero barrier by getting the exterior envelope down as low as they did. And it became the largest net zero project in the state of Utah. So again, 2 different projects, single family and multifamily, for how you get to net zero effectively with a very tight building envelope. I hope that was a couple good illustrative examples. And that's really all the slides we have. Now, Troy and I are happy to take questions if questions had come in, or even if questions come in now. And I believe, Aaron, I don't know if you had any questions come in, or.
We must have all experts on the phone. I haven't seen any questions yet today. Please enter them in the Q&A section if you have a specific question. I know one question I asked when we came online was, what's the maximum amount of square footage of home you're able to seal without having to partition that home off? Troy, maybe we can answer that again live for the audience.
Yeah, sure. So we do get this question a lot. When we're looking at about 10,000 square feet, that is at the level where we start to evaluate bringing in another fan. So the only criteria, the only box that has to be checked for aero barrier to be installed is we have to be able to pressurize the space to about 100 Pascal. So as the space gets bigger, we just bring in more fans. That's it.
Okay, great. And Troy, a question just came in. What's the best stage to do aero seal envelope with the aero barrier product?
Sure. It's a very good question. So I would say 99% of our installs are done after drywall and first coat of mud. It works out very, very well during that stage of construction. And I'll use that to talk about another question that we get asked a lot. So during that stage, there's that recommended 24-hour dry out time anyway. So we can come in and seal the house, and we have no negative impact on the curing of the mud. So in that gap of scheduling, we come in, seal it down, and move on. Besides the house being exponentially tighter, nobody even knows we were there. With that, though, I do get a lot of questions about what does the house look like after we seal? Is there going to be a residue on the wall? Is there going to be a residue on the floor? And the answer is no. Right after the seal, there's a little bit of sealant that'll fall out of suspension onto the floor. So your boots will be a little bit tacky when you walk in. That dries out after about 45 minutes. and people can come in and continue to work on the house. Excuse me. And it will not stick to any vertical surfaces, and it's due to the way it actually seals. So the sealant's floating in suspension rather than rather than having a hose spraying it, if that makes sense. So.
Question came in: how is aero barrier different than other sealants when there is dust, sawdust, etc.? And I think you kind of alluded to that. And then maybe a follow-on question to that: talk about maybe the chemical part of it, that this is a non-toxic, tested material. Can you kind of hit those 2 points?
For sure, for sure. That is a very, very common question. Thank you for bringing that up, Aaron. It's a very, very important question. We want to be cognizant of anything that we're putting into a build. So our sealant is actually an acrylic-based sealant that is 80% water, and it's Green Guard Gold certified. So for folks out there that are not familiar with the Green Guard Gold certification, it's one of the most stringent certifications a sealant or a building product can get. Oftentimes, when that's a requirement for a project, it's in projects where the most vulnerable of people are going to be in that space. Whether it's whether it's elderly people receiving medical care, or young folks in NICUs, or in educational centers. So, and Bill has a lot of experience with that. He did a lot of work in the educational space, and we talk about that a lot. So, thank you, Aaron.
Yeah. And is there any interface with dust, sawdust out in the field?
No, so no sealant. I mean, effectively, no sealant will stick to dust and then stick to something behind it, right? That's just not the way that it works. Right. But since not all of us enjoyed physics class, I'll throw that out. But considering the aero barrier process works on the principles of physics, it's going to find the leaks and seal them. And we are, like, I don't want to brag too much, but we're the only product kind of service out there that guarantees that your building reaches the air tightness level that you're looking to achieve. And it bringing up the dust, having us on the job site does work through a QA/QC process as well. Air sealing is extremely hard. That's the only thing we do. So we're evaluating, where is that dust accumulating? What's being missed behind that? Are you using seal that's not adhering correctly? Are the insulators trying to seal the bottom plates and the top plates, and we're finding that's not working? We can help address that with the builder and work as a team with the entire construction group to make sure everybody's getting exactly where they need to be.
Yeah, I think it's that feedback process, right? Of you're seeing where the gaps are and being able to feed that back to the construction team. Bill, you had something to add there.
Just that when our installers, it's quite common for our installers during the sealing process to go inside the space. And the reason they do it is just to check and make sure everything's going well, adjust the placement or direction at which the placement of our sealing stations, or the direction in which they're spraying the sealant into a fog. And the important thing about this is when they go in, they don't have to wear a Tyvek suit or anything. They essentially wear like what somebody would wear when they're spraying paint, just a face mask covering their eyes, their nose, and their mouth. So just a respirator like that. So that it speaks to the non-toxic nature of the sealant.
Yeah, incredible. This is a great question. And is it possible to use aero barrier on a completed house? And I'll give you my take after having seen an installation. Like, every house I move into from this day forward, like before I move in, I will use AeroSeal envelope and the aero barrier product and seal that thing up as tightly as I can. But Troy, please go ahead.
Yeah. So finished spaces, we can definitely seal them. There's a little more prep that's involved. So that's it. So as I had mentioned, our sealant won't stick to any vertical surfaces, but as it falls out of suspension, it will land on horizontal surfaces. So we'll want to cover that up. Countertops, lighting, appliances, flooring, things of that nature. Our sealant, you can clean it up. We have called Buckeye Cleaner. It's a very environmentally friendly cleaner that all of our installers use in the event that there is some overspray or the sealant sticks on something. But I mean, it's a silly analogy, but I always say, you could have the best mop in the world, but it's better not to spill the water, So we just go out of our way to prep everything, and in the event that sealant does get on something, we can clean it up.
Great. Specific question from Rob Dunker. Does the Aero Barrier product have a CCMC evaluation for use in Canada?
It's a very, very good question.
I don't even know what CCMC
Neither
stands
do
for.
I. That's
Yeah, let us know.
Rob,
what that
maybe
is.
you can detail that in the comments, but I do know that Gord Cook does a lot of Aero Barrier installation throughout the greater Toronto area, and is extremely involved in codes and standards in Canada. I would think that it has whatever is needed, but I don't know what specifically the CCMC is. Troy, maybe you can expand on that.
So I don't know what it is either, but that to me is something that I need to know. So my contact information is on the page. And who asked that question?
It was Rob Dunker. Rob, if you could follow up on that. And
yeah, Rob.
I'm literally
shoot that
Googling.
information over to me. I'd love to learn more about it. As Aaron said, we're doing a lot of work in Canada. We're expanding, over to Europe, Australia, a lot of different areas of the world. So if that's a blind spot, I apologize, but with your help, we can address that right quick and in a hurry. So thank you, Rob.
It's the Canadian Construction Materials Center, National Research Council Canada.
Got it.
Assesses compliance with Canadian building energy. So I mean, what I know to be true is I think there are maybe thousands of houses in Canada that have used the Aero Barrier product. So my guess is, so we got an expert here. CCMC is the only code compliance assessment service for construction products in Canada. Yeah, great. So here's another great, or a follow-up to that previous question. So what about using Aero Barrier in a furnished house? Builder says it's too messy and will be a huge cleanup problem. Again, I think it's like you got a hell of a lot more prep work there, right, Troy? But it could definitely be done.
Yep.
Yes.
It can sorry, go ahead, Bill.
Well, I was just going to say, we actually in Rochester, Minnesota, we did an affordable housing project with about 120 apartment units that had been completed, and then they couldn't pass their blower door test. So they literally were putting up families in a hotel, a nearby hotel, at X number of dollars per night because they couldn't get a certificate of occupancy. So they brought in Aero Barrier, and we sealed every one of those, about over 100 units that were finished. They were not furnished at the time, but they were finished. Did include light fixtures. And we did exactly what Troy said, covered up the carpet. We actually bagged the light fixtures suspended from the ceiling, covered up the countertops. If you were doing a furnished house, you would essentially want to move furniture to the middle of the room and drape it with a drop cloth or plastic, just like a painter would.
Yep. Now, I will say that, if you were to ask one of our installers, they would probably have a conversation with the homeowner about any type of liability for, if there was some sealant that got on, their wedding dress or something like that. But yeah, I mean, it's been done. It actually is done a lot in Canada. So
yeah, we have an installer in Canada who all he does is existing homes.
That's right. So just more prep work. Can you share with everyone kind of rough costing? And I think there's always that caveat of, I think it depends how leaky is the house to begin with. How far down do you need to bring it? I think that's really an incredible piece of it, that, you can be at 5 ACH and need to get to 1.5. You're going to have a longer run time. But can you talk roughly about that cost, Troy, for people as they think about this?
Yeah, for sure. So when there's kind of two things that I want to address, and Aaron, you really hit on both of them. What we're seeing is, when we're getting from 5 or 7 air changes per hour, maybe 8 or 9, down to regular municipal code, when we're looking at 3, typically you could say 85 cents to $1 square foot is is on par with what that costing would be. Volume obviously has a major impact in that as well. I mean, that's purchasing anything from aero barrier to bread. Volume is part of the equation. When we're looking at getting down to 0.5 or 1.5, that cost could go up a little bit. But the great thing about aero barrier is really it requires a little bit more upfront work and the equipment running a little bit longer. So going from 3 to 1.5 is not a major feat for us. Bill had mentioned, we're in almost every Beezer house right now. They have that net zero ready initiative, and we're sealing all those as well as many other builders that are building to net zero ready. So 85 cents to $1. If you're getting out of that 1.5, maybe a little bit more, but that's pretty comfortable price range.
That's great. Well, Bill, I think that we'd love to have you back. I mean, based on the interest, and talk perhaps more about the AeroSeal duct product
Sure.
as well.
Yeah, absolutely.
I think that it's the same physics principle for
Right.
really sealing ductwork throughout the buildings. There's always that piece of, because I know, Troy, the installation I saw, that builder actually didn't have an ERV in the house, so you could only seal it down to 3. I think that's a big shift that we're seeing in the new 2021 IECC. It looks like ERVs, HRVs are required in climate zone 7 and 8. We think in the 24, it's going to go to climate zone 6. If you live where I live here in Minneapolis, you already have to do it. But an ERV is a critical piece of that total sealing. And then you've got this fresh air ductwork distribution system that you may want sealed very tightly as well.
Yep.
So is that generally the same installer that can do the AeroSeal duct product, or is it a different subcontractor?
That's a very good question. So we do have installers that do both. Typically, though, on the AeroSeal duct side. So I'm still working with the new branding here. On the AeroSeal duct side, what we're seeing is the HVAC installer will normally be the one that does it.
Okay.
And the reason is, you can think of just with aero barrier how it increases the efficiency of air sealing a house. It also does that when the HVAC installer is installing the ductwork. So instead of spending hours and hours running around with tape and mastic, they can seal the ductwork using AeroSeal duct and get that down to 1% leakage. I mean, seal it just as tight as your requirement is. Depending on where you are, feel free to reach out to myself or Bill. We'll be able to discuss your project, connect you with the appropriate installer, and answer any questions for sure.
Yeah, maybe that's a great final question. Is there really anywhere that you can't do AeroSeal product?
No.
Really.
Yeah.
We have installers across the entire United States. We also have our own direct install crews and commercial team as well. So no, I mean, we're sealing up in the mountains in Colorado, and in the suburbs of Charlotte and Dallas, Texas, and Houston, everywhere in between. So
Yep.
One thing to think about is, I know we've had some EBA members that have purchased an AeroSeal rig.
Yeah.
And that is definitely a possibility. If you're doing enough volume, or if you have enough interest in this, I think Troy would definitely reach out to you about that, right?
For sure.
Yeah.
Our typical installers, I don't even want to say typical, because various different folks can find value to better serve their clients in various different ways, whether they're consultants and raters or insulation companies or home builders, that are building and saying, hey, I want to use this on my houses, but can I also make a business out of this? And overwhelmingly, the answer is yes. So
yeah, that's great. One final question that just came in. Is it quite flexible? Will it move with the building and with temperature changes?
Very,
it's
very
a-
good question.
Yeah, it's a caulk, right, Troy?
Yep.
When it
So-
dries, it's just like caulking.
So it has a plus or minus 20% flex rating. So it'll deal complete with the expansion and contraction of the house. And then we did a 50-year lab test, which showed virtually zero depreciation in the integrity of the seal. We go back when we can and test houses to see, what that air tightness is and how it's been impacted. Most people don't like us to come back and test their house. They had a builder build it. Now they're living in it. They don't even know who we are. They just know they have a great house. But there are some that we're able to go back and test. The last one, I think it changed by 0.02 air changes per hour, which is within margin of error for a blower door anyway. So
Yeah.
virtually
And I think
zero
that was,
depreciation.
I think that was after 5 years of being lived in and going through 5 years of a 4-season weather cycle. So, hey, Aaron, one thing I wanted to mention real quick is just that we're very excited to be coming to the EV conference again. We're normally there every year, but now for the second year, we're doing an educational presentation, and we're teaming up with actually Gord Cook, who you mentioned, from Building Knowledge and Construction Instruction, and we're going to be presenting a session on the carbon impact of a tight building envelope.
Yeah.
Because as we know, carbon, both operational and embedded, is growing in interest, and desire for information is faster than the interest for net zero and zero energy ready. So we're really excited to come to Salt Lake City and lead a session on that.
Really interested in that topic, and looking forward to that. So, Troy and Bill, I just want to thank you so much for presenting today. I always learn something new. And it's just such an incredible product. It sometimes seems too good to be true, right? But it's not. It's really not. So I want to thank you. This recording will be up at eva.org in the Academy, recorded, and will be on the Better Homes, Better Future podcast and available. I think we can get some copies of the slides, perhaps,
Yes. Yep.
Bill, and we'll
Absolutely.
share those in that location as well. So feel free to share it with other people in your organizations. And thank you so very much.
Yes. Thank you very much, Aaron. Thank you,
Yep,
Nancy.
thanks for the
Much
opportunity.
appreciated. Thanks for everybody that sent it.
Bye.
Thanks, everybody.
Thanks, guys.
Thanks.